Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 48 rotated image. We're told that we're given an n by n 2D matrix representing an image. Rotate this image by 90 degrees clockwise. And we have to rotate the image in place, and which means we have to modify the matrix directly, and we can't allocate another 2D matrix and then do the rotation. Okay, so judging by n, and the fact that we're told that it's a square matrix, we know that we're dealing with a square. So any matrix that we're given is just going to be a square, no rectangles, no other odd shapes, just a square. And we're given some constraints, and we need to shift the image 90 degrees clockwise. So in this example, the 1 is shifted to where the 3 is, the 3 is shifted to where the 9 is, the 9 is shifted to where the 7 is, and the 7 is then shifted back to where the 1 was. Okay, so let's get coding. The first thing with any matrix problem is we want to have, but in this case we want to have a left and right pointer, because we are going to do the first layer and then we want to do the second layer. So we want pointers, left and right, and a top and left pointer, and every rotation we want to increment those pointers or decrement if need be. And once those pointers meet each other, we know that we've done all the rotation needed, and we can end our code. So let's store our left pointer at 0, int left equals 0, and int right equals the length of matrix 0. It doesn't have to be matrix 0 because we are given a square. It could be matrix.length or matrix 0.length. I'll just do matrix 0, but it doesn't really matter because again, square, so all sides are the same length. And then we want to say while left is less than right, for, and then we want to say, so let's say we've got 3 elements in a row. In this case, we've got 4 elements, but for each element in the row, we want to do the rotation. So we want to rotate each time. So we want to say for int I equals 0, as long as I is less than the length of right minus left, we want to do I plus plus, so we keep incrementing while until we finish the length of right minus left, so the length of a side basically. And we also want to set our top and bottom pointers, like I said, but again, we can set these to the left and right pointers respectively, because we're dealing with a square, so all sides are the same, and because of that equality, we can set those top and bottom pointers to left and right pointers. Okay, so now comes the time for rotation. Well, you could say, when we move the 1 to 3, well, then we need to store the 3 in a temporary variable, then the 3 to a 9. We need to then store the 9 into a temporary variable, then we need to store the 7 into a temporary variable. So you've got lots of temporary variables using extra space, and there's an added complexity. What if we could move one element and store only one variable temporarily, and then shift the rest without having to worry about anything like that? And while we can do that, we can remove the top left, store that into a top variable, and then shift each cell by 1 without having to worry about storing those cells or the values of those cells in temporary variables. So let's do that. Let's store the top left. So we're going to say int top left is going to be equal to the top and left, digit at the top left. Okay, what do we want to do now? We want to say bottom left to top left. So the bottom left is here. We want to move it to the top left. So we can simply say matrix bottom left equals matrix top left should be equal to the matrix bottom left. What do we want to do after that? We want to put the bottom right into the bottom left. So we want to say bottom right to bottom left. So matrix bottom right is going to be equal to matrix bottom left. And then what do we want to do after that? We want to put the top right to the bottom right. So the top right to the bottom right. So again, we want to shift that by 90. So top right to bottom right, matrix top right is going to be equal to matrix bottom, matrix top right, yeah, matrix bottom right. Yeah, that's correct. And what can we do after that? We can say, let's put the top left to the bottom to the top right. So top left to top right. So we'll do matrix top right is going to be equal to top left, which we stored initially. Okay, but we are missing one thing, aren't we? And that's the fact that we have a I variable. We need to basically add I to all of these calculations. So we want to offset each position by I. So top left, we can shift this by 1. So remember, if we look at 1, 3, 9, and 7 as a single square, but we need to shift these elements. So imagine 2, 6, 8, and 4 as also another square. So you can see 4 goes to 2, 2 goes to 6, 6 goes to where 8 is, and 8 goes to 4. So there's multiple squares. So there's 2 squares that we need to shift within this single square. So we'll shift this by L plus I. We need to also increment this by I, and then the bottom right to the top left. So bottom is going to be at minus I as well, because we want to put it up, and right, bottom right to bottom left. Bottom right to bottom left. No, that should be okay. So matrix top right to bottom right. So top right is going to be, let's have a look. So top right to bottom, this is wrong actually. I'm just looking at the code now. So this should actually be bottom right, and this should be top right. Okay. So let's say, well, if we have the top right, so the top right is this one over here. We want to put this to bottom right. So bottom right equals top right. Yeah, that's correct. So bottom right, so that's going to be bottom, and then we want to do right minus I is going to be equal to top plus I, and then our right pointer. And the left pointer, again, we need to do top plus I, which is just going to be equal to top left. So let's just have a look at that again. So L plus I equals bottom left to top. Actually, this should also be bottom I, bottom minus I, and then bottom minus I, bottom right to bottom left. This should be bottom left, actually, bottom left. This should be bottom right. And again, we want to decrement this by 1 because we're moving this inwards. So we want to shift this cell by 1 as well. Right minus I. Top plus I. Yeah, that looks good to me. Let's actually, no, our code's not finished yet, so our test case won't actually do anything. And we have a error here anyway. So we need to put a semicolon here, but also once for each iteration of once our for loop is finished for that rotation, so for that layer, we want to say we want to decrement our right pointer, or if we want to increment our left pointer and decrement our right pointer. So now let's run our code. Let's check we pass, and our solution passes all test cases. I need to put a semicolon there. Index 3. So we have an issue here. So we're moving the bottom left to the top left. So bottom top left plus I. It's going to be bottom I minus L. Okay. L plus I is IL. And the error we're getting is it's just a compilation error, is it? Let's run that again, or is that an out of bounds error? Oh, it's an out of bounds error. So index 3, out of bounds for length 3. What test case is this? That's a test case, okay. So bottom left. I've got it. So this is actually top I equals bottom minus IL. Yeah, that makes sense. I think I see the code now. I think we need to actually decrement this logic by 1. So it should be the length of the matrix minus 1. I believe this is the issue with our code. So our right pointer needs to be, and that's it. Amazing. So we pass all 21 cases. Okay, so we want to remember, because of zero-based indexing, we want to decrement our right pointer by 1 before, or basically our right pointer should be equal to the length of the matrix minus 1. Okay, that makes sense. So in terms of our submission, we do pass all test cases, then fantastic. So in terms of time complexity, we're looking at an O of n squared time complexity, and space complexity, we're looking at an O over 1 space complexity, because we are only using auxiliary variables and no extra space, including everything in place. Fantastic. So there were a couple of hiccups at the end, but I hope you guys did enjoy this video and it made sense, and I'll catch you in the next one.